Bruce Ames. So my job, it's a really pleasurable job, is to now introduce Senator John Blake. In order to introduce him, you really have to put things into a context. So I'd like to share with you a very interesting thing that happened not 2 weeks ago. I was walking in one of the residential neighborhoods in Scranton, and there were a bunch of kids. Remember, it was like this time when it was really warm in March, and there were a bunch of kids playing in front of a house, and they were about 8 to like 12 years old, around there, and they were actually playing a game of good guy, bad guy. I don't know if it was cowboys and Indians or cops and robbers, but it obviously was based on good and bad. And as I'm walking past, one of the kids cries out and says, "But I don't want to be a politician." And you know, today, after so many years now of this constant drumbeat about politicians, I mean, it's not like they came from another planet and they've invaded. These were elected officials. So, you know, it's not like they're strangers to us, but the general feeling about the word politician is that it has denotations to it and negative affect that it raises in people. We have in Scranton our state senator who is completely different. Senator John, I'm not going to go talk about achievements. I'm just going to talk about what we have, the resource and the treasure that's our state senator. We have a senator who is concerned with knowledge and detail. No topic that the senator gets involved in is not studied. And when he speaks with the authority of knowledge. We have a senator who basically is not distant from the constituents. The senator doesn't have Republicans or Democrats or independents in his area. The senator has people, the people that he represents. He's an asset to the city of Scranton. He's an asset to the University of Scranton, where he's on the faculty also. And he's an asset to the people of Pennsylvania. I would like to find out if 3-4 years from now, if that same kid that says, "But I don't want to be a politician," might not want to be one after they see what is accomplished by Senator John Blake. It's my personal hope that shortly he changes his address either in Harrisburg or maybe decides to go for a long-range move and change it into an address in Washington. But no matter what, we are all very, very lucky that this is the person who we've elected to represent us and to also take interest and care for our elderly. Without any more delay, Senator John Blake.
Thank you, Herb, for that very kind and somewhat humbling introduction. I'm very, very happy to be senator. I'm not going anywhere for a while, but I'm deeply grateful, Herb, for that introduction. You know, it's very special for me, ladies and gentlemen, to be here, and an honor. And as a state senator for the 22nd District, I recall the expression that you have 2 ears and one mouth, so listen twice as much than you speak. And part of my learning at this event informs my judgment on the issues that are so important to all of you, and the reason that you're here. You know, Dr. Hauser, before I get into some of my prepared remarks, I want to comment on Dr. Hauser's previous discussion about the trajectory of this year. And I was here last year. I don't quite remember the tornado, but I do recall being here last year, and I remember the intention and the seeds being planted in his discussion about what this year has produced in terms of engagement. And then I take a look at what we're dealing with today and the thanks that are due, because we do have, to the expression that was made earlier, institutional engagement. We have the University of Scranton, as well as representation from the other academic institutions, and Dr. Townsend from the Commonwealth Medical College. You also have the engagement of the physicians and the healthcare professionals and social workers, of which I claim to be the only MSW in the General Assembly, with great pride. And you have the support of Blue Cross of Northeastern Pennsylvania. All of this is progress, and I think you should be proud, Dr. Hauser. I know the university should be proud for that progress, and I know it'll continue. So let me say thanks to the university, to Reverend Quinn, to Dr. Hauser, to those that made possible the second annual conference on aging. Let me say thanks to all the panelists and all the participants, and thanks to all of you for being here on such an important matter. You know, I hadn't heard this quote yet from anyone that has presented, so I guess I can use it. But Mark Twain said, age is an issue of mind over matter. Aging is an issue of mind over matter. If you don't mind, it doesn't matter, right? But listen, we may not mind, but Pennsylvania is an old state and currently ranks 5th in the country in terms of residents over 65 years of age. It was remarkable to hear Dr. Haboobi say 80% will be over 65 years of age, and 20% of that population has to support the 80% that are aging. It's an extraordinary demographic reality. In my Senate district alone, there are 43,700 residents over the age of 65. Counts for about 17% of the population in my district. And now more than ever, these seniors need our help. The cost of food, prescription drugs, we've had remarks here from Eric Pusey, who's a great gentleman, and I think we heard a little bit today, and I'll digress a little bit here on behalf of Eric and the small pharmacies. They're close, they're responsive, they know the people that they're serving. They're not distant, they're not corporate, they're not mail order. There's some real value in that, and we need to defend that value, and I appreciate Eric's participation here today. Anyway, the cost of food, prescription drugs, and traveling by public transportation continue to increase, and you also heard Dr. Townsend mention that we are in austere times. And tough decisions are being made in Harrisburg. And I won't be partisan out of respect to the governor and Secretary Duke and the executive branch that are represented here. But there are policy decisions and resource decisions that are being made in Harrisburg that have tremendous consequences on the population. That's the subject of this conference. Simple one. You may not know too much about this, but a little voter ID bill out there that says you have to bring an ID to vote in November. It is now the law, although there are some challenges to it, but that's an issue for about 340,000 seniors who may not have it. And it seems a simple issue, but anything that changes, I think, the bar associated with one of the most important rights that we have in this democracy is something of concern. The other one has to do with some decisions by the Department of Public Welfare to institute an asset test, if you will, for the Supplemental Nutrition Assistance Program, the SNAP program. And this policy issue, again, is a function of scarce resources, but it's also, I think, sends the wrong signal to our seniors with regard to savings. It only takes a singular incident to wipe out $2,000 or $3,000 just to keep a car on the road. Those people who require that assistance and that nutritional assistance provided by the federal program, I think putting the asset test in is really not the best public policy, but again, we will debate it. And then the last one, which is more recent in vintage, and to his credit, the governor has been on the record that this is very, very preliminary, but there's an issue of privatizing, not privatizing the lottery, but privatizing the management of the lottery. And this is an issue of concern because the moment you step outside the what I would call the system that currently delivers the lottery and the benefits of the lottery to our seniors, you're going to incur some costs somewhere, right? There's going to be someone who's going to have to make money doing that, and I think that becomes an additional cost. The question is whether the cost benefit is worth it, and I wonder about the full vetting of that. So we're hopeful that the legislature will be consulted on that process. The details are still emerging, and we'll see what happens. Obviously, the biggest issue that we've heard a little bit about earlier today, and an issue for me, is long-term care. And the issue, the cost of long-term care. According to the Pennsylvania Healthcare Association, almost 70% of seniors who will turn 65 this year will require some form of long-term care over the remainder of their life. In Pennsylvania, a senior or their family can expect to pay $96,725 per year for a private room in a nursing home. The national average for a private room is only $77,000 per year, so we in Pennsylvania are about $20,000 higher, which is actually not good news. And I know that the Secretary will talk about this, and I have great confidence in his leadership at the Department of Aging. The issue of how we deal with the housing and the independence and the autonomy and the dignity of our seniors. This is really what this conference is all about. This issue of long-term care is paramount, and certainly the entire debate on healthcare, is a function of the demographics that we're talking about. and the users of it as we age. And we have to find better ways to manage scarce resources to guarantee the dignity of the seniors that are aging in our neighborhoods. The other thing I guess that's important to say is about the options, and I heard this here, and I want to commend the people who raised these questions about the engagement of the seniors themselves and the solutions we devise. I've had a chance since I've been a senator over the past year or 4 months to run around to the senior centers, and I'm telling you, it's some of the most enjoyable and most exciting and most engaging dialogue I can have in my district. So I'm very encouraged to hear Dr. Hauser talk about the growth of this conference and the necessity for that engagement to talk to the people who are affected by the policies, by the decisions, by the research, and by the healthcare professionals that are serving them. So I hope that's an important evolution of the conference. You know, I have a responsibility as a legislator to guarantee that we're improving the quality of life for our citizens. That's my primary responsibility. It's our primary responsibility in government. Notwithstanding what Dr. Hauser said about a politician, and let me divert a little bit to a story. You know, I was over at the Gino Murley Healthcare Center on Veterans Day, and I just went over to, you know, acknowledge some of the veterans that were there on that day. And a gentleman rolls up to me in a wheelchair, and he looks up and he says, "Who are you?" And I said, "Well, I'm Senator John Blake." "I don't like politicians," he says. And I leaned down to him and I said, "Well, neither do I, but somebody's got to do it." And he laughed out loud and he said, "Okay, I like you." But in any case, the job has to be done, and we have to make tough decisions in Harrisburg about scarce resources. And I want to tell you that inside the institution, the responsibility is enormous, and I have deep respect for my colleagues on both sides of the aisle and the governor because of the challenges that we have to face in dealing with the austerity and you know, the things that I teach my kids here at the university about government. For every dollar we take out of the private sector, we better be giving a dollar back in value, or we shouldn't be taking it. That's the true economist point of view. And the other thing is, how do we allocate scarce resources within government? Because we can't spend the same dollar twice. And those two issues prevail upon how we manage care for our seniors, how we engage them, how we serve their needs and increasing needs across the forward horizon. So I'm hopeful that we will move forward out of these challenging economic times and be able to provide the essential services and care not only to our seniors, but to their families. And we heard that a little bit about that today. I've had some really extraordinary experiences as a senator, and I need to talk about this a little bit. There are circumstances that are, I think, new, not only because of the sheer number of seniors that we have, but also new in terms of the challenges. As an example, grandparents that are parenting, again, a new generation of raising their grandchildren. I've encountered that as a senator, where I've had people come into the office seeking some support, seeking some respite from that challenge and those demands. This is a relatively, I think, new and growing phenomenon. I think that the issue of parents my age, my wife and I, you know, dealing with our aging parents and the resource issues that I've mentioned, and the cost issues, and the angst and the stress of it, which has already been discussed in this room and will continue to be a subject of analysis going forward. You know, my dad sold his house. We spent down all the assets, and fortunately my sisters and I were able to continue to contribute to the cost of his care going forward. My wife, the same thing with her mom. Sold the house, spent down the assets, eventually relying solely on the state or the federal government for the dignity she could live until her passing. And even right now, my wife is dealing with an 88-year-old cousin who has no family but her, and she's responsible for his care. And the decisions that are made, the financial matters, the issue of, and sometimes guilt that comes into these relationships because am I doing enough? Am I making the right decisions? These are very, very, very personal and very, very difficult challenges which need to be informed by the conduct of this conference and the participation in it. And that's why it's so very important. The housing issue is brought up. I think of the different places where the state government touches this matter. We certainly touch it in the Department of Public Welfare. We certainly touch it in the Department of Aging. We touch it in the Department of Health in terms of our regulatory control over the institutional settings throughout the state, the nursing homes and the assisted living facilities. We touch it in terms of the dollars that are made available for housing. When I first began in public life, I began basically writing grants to fix up homes in Lackawanna County. It's where I cut my teeth in public life, and most of the people that I assisted were fixed income seniors. We put a roof on their house, we put a new porch, a new set of steps, a new electrical system, a new heating system. And that's where I began to understand the interface of taxpayer dollars and the public good. and it was an economic development issue too. One of the questions that was raised earlier by one of the persons here had to do with the issue of economic development and diversity of our economy. If we don't keep the young people here who are coming out of our educational institutions, who are going to be here to take care of that growing aging population? And there are enormous economic drivers here in the healthcare field. Excuse me, we talk about the eds and meds and how that sustains a regional economy. But the healthcare and the assisted, the allied providers, healthcare providers, the physical therapists, the social workers, the nursing profession, all of these are important supporters of the quality of life that our seniors can enjoy, and we need to support that economic base, if you will, to guarantee that we can deal with the demands that are going forward. One of the things I learned during appropriations hearings, and I know Secretary Duke will nod an affirmation on this, is that when we are flat funded, we are losing ground. The secretaries will come and say, I'm getting the same amount of money I got last year, but the demand at my doorstep is 2 or 3 times that. And we also heard it here about Meals on Wheels. 800 meals a day, it's going to be 1,000. It's going to be 1,500. If we are flat funded, we're losing ground. So the issue, again, of allocating scarce resources and the kind of priorities and the kind of fairness and the kind of discipline we need to show in allocating those resources is really my job in Harrisburg. So I guess I really want to conclude my remarks by just saying thank you. Thank you to the university, thank you to the community for making this possible, for bringing professionals together, for allowing the engagement, for expanding the collaboration, for getting the right people in the room to talk about this, because the research that's done here and the information that's learned can inform our policy decision and can inform our resource allocation decisions. And I know you'll hear more about that from the Secretary. So I want to commend you for it. I want to basically let you know that it means a lot to me to be part of it. I will hope that I will continue to be invited back each year to be part of the conference as it grows, and I look forward to being a strong advocate to make sure that we are adequately resourcing the needs that need to be met for a growing senior population. So with that, I'm going to conclude my remarks, and I have a great pleasure in introducing Secretary of Aging, Brian Duke. It's a real pleasure for me to introduce the Secretary, quite simply because our first encounter, or among our first encounters, was at the conference last year, and of course during his process of being confirmed. And it's a real testimony to the Governor's eye toward the work being done by this conference to have a member of his cabinet in this room, and I think you should be proud of that and grateful for it. Brian was nominated by Governor Corbett to become the Secretary of Aging in February of 2011. The department oversees many services and benefits for older Pennsylvanians and advocates for their interests at all levels of government. Prior to his nomination by Governor Tom Corbett, the Secretary served as Director of the Bucks County Area Agency on Aging. Before that, he served as Executive Director for the New Jersey Foundation for Aging, a statewide public charity dedicated to improving the quality of life for older persons. And prior to his work with the foundation, he served as a consultant working with the U.S. administration on aging and the AARP Foundation in the development of statewide caregiving coalitions in 12 states. He served as director of the geriatric program initiatives with the Institute on Aging at the University of Pennsylvania Health System. And prior to this, he was in the field of hospital administration for 20 years, including services as an administrative director of physical medicine and rehabilitation for St. Mary Medical Center in Langhorne and the Bryn Mawr Rehab Hospital. He holds a BS in business administration from the University of Scranton. And he told me not to listen to anything about his time here. He was constantly in class or in the chapel, right? Okay. But he also has a degree from George Washington University and an MBA in bioethics from the University of Pennsylvania. He's an associate fellow at the Institute of Aging of the University of Pennsylvania, and it's a deep pleasure for me to introduce the Secretary of the Department of Aging, Brian Duke.
Good afternoon. I want to thank Reverend Quinn for his welcome today, particularly the welcome home. It's always good to come back to campus. I took a walk last night with Tom Sneddon, who I thank every day for his service leading our pharmaceutical assistance program, and I was telling him different parts of the university weren't here when I was here. I think our classes were held in one of 3 buildings, and to come back and see what has evolved here is really a pleasure. So it's good to be home. Thank you, Senator Blake, for that introduction and for your comments. And share with you the advocacy and passion for Pennsylvania's elders. Thanks to Dr. Herb Hauser and all who organized this conference. What an event, and do put me on the invite list for next year so that we can continue to come back and hear the progress and see the progress at this conference and hear of the activity that's so important to our older Pennsylvanians. Thanks to Dr. Lois Nora, the interim president and dean of the Commonwealth Medical College, for a visit I had there yesterday. It was indeed a pleasure to be able to visit the medical college and sit down with Dr. Townsend and others to talk about what's evolving at this wonderful newest medical college in the Commonwealth and its impact on Pennsylvania and Pennsylvanians, and it was great to hear that. And I know Dr. Brian Conniff will be with us later. So I'm always grateful to be home, as I said. I thank those who've shared their insights today. Most importantly, the research that we're hearing about. The dialogues that are taking place today are indeed essential for our futures, a future where all Pennsylvanians can age and live well. You've heard about the demographic challenges we face. Indeed, we know in Lackawanna and Luzerne counties, and I know representatives are here from the Area Agency on Aging. Mr. Calvin Holmes, who's the newly appointed director, Mary Gaffney's here from Lackawanna, and Jackie Sturgis from Wayne. So we welcome you all for being here. Any other AAAs here that I may have missed? These AAAs are our 52 front doors, so I thank you for your engagement. We know that the population continues to grow, and we can see it in our services. I mentioned Tom's here with the Pharmaceutical Assistance Program, and on average in Pennsylvania, when you look at the elderly population and the total number of people enrolled in PACE and PACEnet across the state, it's about 17.5%. And when you look at this area of the Commonwealth, it's as high as just over 24%. That tells us a lot when you consider the economic eligibility for that program and you consider the number of elders in this region. And so that is a program that supports many. We know that with the dollars that come to us from the lottery, we mentioned about the private management initiative, but really recognizing the value to all of Pennsylvania of the lottery. When you hear that tagline for older Pennsylvanians, 75% of our budget comes from the lottery. And indeed, in this region, $67 million is distributed across Lackawanna and Luzerne County for services to our older populations. Today's conference has panels broken out in several key areas. You know, we've heard the panel on basic research and community health. And this afternoon, there'll be panels on education and clinical practice. It's necessary, and I stated this last year, that these four arenas come together in a very collaborative process so that we can take those lessons learned from valued research, whether at the laboratory bench or in other arenas of qualitative or quantitative research, and translate them to real practice to make a difference in the lives of our elders. And so I am very pleased to see today's agenda, honored to see those who are speaking today and learning much with you about what that collaboration could look like. Let me also share with you a little bit about our Pennsylvania Department of Aging and our strategic vision moving forward in terms of how we're trying to broadly position ourselves in order to serve more people and meet anticipated challenges. We're in a very important process right now to create a 2012-2016 four-year plan, and the area agencies on aging are doing likewise. And some of the participants in a focus group we recently held at Misericordia College in Dallas are with us today, and I thank them for their participation in that group. And as a matter of fact, that's how I met Mario, and thank Mario for introducing me to the college yesterday and offering me an opportunity to learn more about what's happening in this region. But for those of you unfamiliar, we have to do a four-year plan and submit it to the U.S. Department, the U.S. Administration on Aging. And it establishes our goals and objectives. But the plan's more than a requirement in these times. It is indeed a way for us to look at our two main areas of commitment, prevention and protection. When we think about prevention, we can think about what we do in health and wellness in terms of activities, educational outreach, and other forms of intervention. We also can think what we do is we provide our day-to-day services in homes, in communities across the Commonwealth. And how do we look at that? And how do we determine we're doing something that's effective? We talk about protection, we can talk about protective services that we provide to help protect people from abuse, neglect, exploitation, and abandonment. But we also have to talk about what we find as we deliver care. And so as we engage those and leaders in the field such as yourselves, and we engage those we serve, there are three main strategic directions for us moving forward in the next 4 years. One, we will ensure that all Pennsylvanians will be able to age and live well, and equally important, making sure our communities are places to age and live well. Second, we will ensure that Pennsylvanians have access to care at the right time, with the right intensity, in the right setting. And third, we will bring the best of Pennsylvania to Pennsylvanians through the sharing of best practices and support of entrepreneurial ideas. And starting with that last one, there's common ground here. You are the best of Pennsylvania. I keep saying this is the best university in Pennsylvania and perhaps the country, the University of Scranton. I'm biased, okay. But realizing we have academic institutions represented here from all across the region, you are the best of Pennsylvania, and we need to take the learnings from the research you're doing and see what we can do to translate and replicate that across the Commonwealth. So starting with that third strategic direction, it's how can we partner together? How can we leverage our partnership in terms of seeking external funding? How can we leverage our partnership in terms of sharing databases for research and exploration? How can we do these things together better? That second one about right time, right intensity, and right setting of service builds on our success to date of trying to shift care so that it's equally balanced between home and community-based services and services provided in skilled nursing facilities and other institutions. That doesn't negate the value of those institutions. It just says we have to have a better balance of how we spend those most valued resources for care. To do that, we need to shift the conversation to bring all parts of the continuum to table and begin insurers, managed care entities, healthcare providers, and systems to begin to talk about what does it mean to age well in Pennsylvania? What does it mean to receive care, the right time, right intensity, right setting? All parties are interested in that dialogue, and it's time we come together to talk about it. And that first one about age and to age and live well. Certainly government can't be the sole source of the resources that are needed to achieve that goal, and helping our communities be places to age and live well. We need everyone to come to the table together to discuss what that means. We'll be convening consumer groups in the next few weeks, and a consumer group that will specifically focus on persons living with disabilities. We'll then be drafting a plan and coming back out throughout Pennsylvania to conduct public hearings on a draft plan. I invite you to participate either with your area agency on aging. If you haven't been involved, invited, or you haven't heard about it, give them a call, tell them I told you to call, and tell them that you're interested in what they're planning in the region for those who are older and for persons living with disabilities. Through the focus groups, we learned of the value of our senior centers. We know there's a critical need to navigate care. We know technology, and it was great to hear a presentation today by an analytic chemist, a professional, so thank you, doctor. But it was a little over my head, some parts of it, I'll admit that. But to hear the concept of what we're trying to do to evolve technology to meet needs and help people stay in their homes and communities was indeed the right place to be. We learned from our focus group there's an imperative to understand what person-centered care means and what does it mean to provide appropriate care. We heard that cost sharing and other models must offer significant opportunities for expanding services. At the group in the Northeast, we heard about adult daycare and its benefit for patients, those living with dementia and otherwise, and trying to keep people home. We heard about the importance of socialization, the overall support for the concept of care navigation. We heard about transportation earlier today, and we heard about it at that focus group. And then we also heard for quite a bit about the difference between urban and rural communities. Your conference today stresses a vital aspect of our planning, which has to do with partnerships. To craft the plan I referenced earlier, or define our expectations for moving forward, we have to go beyond the Older Americans Act and require full community participation to determine what our future is and to pursue it with all vigor. And as from where we sit in state government, we need to become fully aware of those partnerships and become a catalyst to help them form. The university's Aging Conference plays a role as an active contributor and a participant in statewide national issues to the dialogue today. I encourage participation from those of us who are passionate about what we do and reaffirm why we've decided to become engaged in not only today's dialogue but the future. Today helps us all reflect upon our missions as a way to assess opportunities that come before us. So again, I thank you for the opportunity to be with you today. Our mission in Pennsylvania Department of Aging is to enhance the quality of life for all older Pennsylvanians by empowering diverse communities, the family, and the individual. To do that, we need to rely upon those gathered here in this room with the expertise that's needed. Again, my gratitude for the fine work you do and for the support of all Pennsylvanians, but most especially our vulnerable citizens, those who are older and living with disabilities. Ignatius of Loyola said, "Love ought to show itself in deeds over and above words." Perhaps the definition of cura personalis, aligned to educator-student relationships, can be extended to our missions dedicated to help others age and live well. Thank you very much for the opportunity to be here. Question? Do you have? I'm sorry. Yeah. Happy to. Try Senator Blake. Any questions?
Secretary, if anybody has any questions, like how much money does he really have to spend, important questions. If not, then we'll just proceed with the midday session, and we'll reserve questions toward the end of the open discussion. So, Dr. Tomna, would you?
We have a question.
Oh, there was a question.
I'm
Sorry.
Yes, sir.
I don't mean this to be political. I'll try to stay away from it, but
Well, aging is nonpartisan, so it's okay.
I understand that, but how do we do all that you say, which is so important, with the way that our government is curtailing and cutting so many of the social services and leading programs in this state?
We realize that the decisions being made these days are difficult. And when you have a time of limited resource, I believe you have great opportunity. And I think the way it's done is we convene in our communities and determine the right way to build partnerships that can respond to need and move forward. Even in good times, and I often ask some of my peers who were here, what was it like when we had money? Even in good times, you need to be a responsible steward of the resources that are before you. And I realize there are different reactions to decisions that are being offered right now and proposed by the governor in his budget, but I think they're ones that are necessary and difficult. But we need to do it in such a way that we engage people in the communities. I often say aging and community are synonyms. They're two words that are synonyms. And we must be a catalyst at the Department of Aging and the Office of Long-Term Living, and working with our legislators who support us so well, like Senator Blake, to bring together the right resources in our communities. Because what it means to age well here in Lackawanna County differs from what it means to age well in Potter County and Harrisburg and Pittsburgh. And we need to engage the right people to find the right solutions. I wish there were more resources. I'm sure the governor would say the same, and I'm sure the senator would say the same, but right now we don't have them. Yeah, sure.
The secretary is correct that these are tough decisions. I would want to augment his comments only by saying that there might be some good news on the horizon. That I think you should be encouraged that the crisis is subsiding and that the growth appears to be returning. That's not a small matter. It's not a small matter. When the governor presented his budget in February, he had estimated a prospective deficit of about $718 million. I believe maybe a little bit more or less than that. But when we see the performance of the economy over these past several months, the deficit is likely to be less than half of that, which is encouraging because it allows some different decisions to be made about the depth of the cuts, about the impact of the cuts, whether they need to be as deep as they are. The secretary is also right about leveraging resources effectively, and I think that's part of what this conference is about. And even Dr. Hauser mentioned the pursuit of grants to help foster additional work here. So that's a constant, there's constant improvement, but I think I'm encouraged by the fact that we're starting to grow out of the mess that we've been in the past 3 or 4 years, and I'm always a glasses half full kind of guy, but I am encouraged by the fact that maybe the decisions will get easier going forward instead of harder.
Senator, does that mean, as a follow-up, does that mean there may be some funding reinstituted for some of these programs and maybe get back some money that they lost?
That's my hope. That's what I'm fighting for. That's what our caucus is fighting for. I think there are people on both sides of the aisle down there that are not unhappy with the true impacts on the people behind these numbers. So if we see some growth, economic growth, and those revenues pick up a little bit, we obviously don't want to be spendthrift, but we want to put money where we're getting the best value and certainly improving the quality of life for our citizens. So the answer to that question is yes, very hopeful for restorations.
Thank you.
Thank you.
Okay, good afternoon, everyone. It's me again. We back to the basic science, but from different and unique perspective, bringing basic science, nutrition, community, and future visioning, preventive medicine. Our keynote speaker today is Professor Bruce Ames. And let me start, first of all, by thanking Professor Ames for accepting our invitation to become and join us as a keynote speaker in the second conference on aging. Bruce is a professor of molecular and cell biology at the University of California at Berkeley. He's also senior scientist at Children's Hospital Auckland Research Institute. And I think some of you wonder what's the connection between aging and Children's Hospital. Well, we view that we start age from the minute that we are born. So best way to describe Bruce's research is as an innovative, multidisciplinary science whose major interest is preventive medicine, as I said. He's tying his basic science research with public health, and always public health was Bruce's concern and interest. Bruce held through his career, which is quite challenging, Bruce, to summarize your career within 5 minutes. I will try to do my best. He held many professional positions. Here are a few of them. He was biochemist and chief laboratory of molecular and cellular molecular biology at National Institute of Health. Then he moved to UC Berkeley, where he became a professor of biochemistry and molecular biology, and also he was the department chair from 83 to 89. He was also the director of NIEHS, as National Institute of Environmental Health Sciences at UC Berkeley, for quite a long time, over 10 years. At present, he is a professor at UC Berkeley, and he is, as I said, senior scientist at Children's Hospital Auckland Research Institute. Now, I tried to map Bruce's career, which is, as I said, quite challenging. Usually, we scientists ask to summarize 3 years project in 100 words. That's probably much easier, but I'll do my best. Early in his career, he focused on cancer prevention, which ultimately led to the Ames test. That test essentially spared millions of people, and still, from cancer. The Ames test, which has been named now and known for that, was developed at UC Berkeley around the 70s. It's currently used to evaluate or measure, actually, what we call genotoxicity, the ability of chemicals to cause toxicity to our genome, to DNA, which can be a serious problem. Another way, testing for carcinogenicity, the ability of compound to cause cancer. And it's almost universally used. A single example of the significance of the Ames test I found essentially very interesting. I want to share with you. Around 70s, when Ames test was developed, there was a chemical called tris-2,3-di-bromopropyl phosphate, TRI-PPS. And this was used in the fabric that made clothes, especially pajamas for children, as a fire retardant to protect them from fire. The Ames test essentially revealed that tris-PPS PP, this chemical, is carcinogen. Damages DNA, binds to DNA, causes mutation, and causes cancer. At that time, this test saved more than 50 million children, and still saving children. So this example demonstrates how a beautiful idea serves the public immediately, instantly, and keeps doing so forever. It's demonstration for the beauty of science. Today, the Ames test is the rule of thumb for testing new drugs and other thousands of chemicals for genotoxicity before they are being used in industry, or drugs, medications that we use. They have to pass the Ames test before get to people. Now, this phase of process carrier was followed by in another phase from towards the beginning of the 80s until the end of the century, the 20th century, and that was directed, this second phase, at preventing mitochondrial dysfunction, which ultimately led to the idea that's published in several of his papers, metabolic tune-up. How really you tune your metabolism to keep it adequate and healthy. And this led to the discovery of lipoic acid and acetylcarnitine as key components to keep you healthy. In the last 5 to 10 years, Bruce's interest focused on understanding the basic mechanisms of aging that involved in the age and diseases of aging and preventing them. So he has a new theory called the Triage Theory that he's going to talk about today. Now, looking at Bruce's CV and accomplishments, I was able to count and do the math. On average, every 1.5 years to 2 years, Bruce received an award. I'm not going to hold you now to go through the list, but this is not to mention the grants. This is awards, and I will list some of them. I'll make jumps here. He received the Eli Lilly Award of the American Chemical Society. He's an elected member of the National Academy of Sciences, National Cancer Advisory Board, appointed by the president. I will make some jumps. He received the Franklin Institute Carson Life Science Award. He's elected fellow for the Royal Swedish Academy of Sciences. He received the Glenn Foundation Award in Aging, Gerontology. He received, it's a national and international. He receives the Honda Prize, he receives the Japan Prize, and maybe the Scranton Prize soon. He receives the Medal of the City of Paris, US National Medal of Science. I remember that because it was in his lab at that time. The Linus Pauling Institute Prize of Health, and he was appointed for another committee for National Medal of Science, appointed by the president, and Thomas Hunt Morgan Medal. And it's amazing. Bruce has more than 500 papers published. Up to the between 80s and 90s, late 90s, Bruce held among the top 23 most cited scientists in general areas. This number moved up a little, probably because his students start competing with him. Sorry, Bruce. But this is, he's still at the top cited scientist in the field. His papers appear in top journals, Science, Nature, BNS, JPC, and the list few. Now, I recall the first day I was in Bruce's lab. It was things before that, but I arrived to UC Berkeley, and I had a conversation with him about life in general, and my little daughter. He was very interested in her, and she's remember him. And at the end of the conversation, I asked Bruce, naturally, if there's any specific project he wants me to work on. And his reply was that his strategy is to let people do whatever they think is important. His principle is let people be free, and they will do great things. Now, this is Bruce Ames. There's one more thing I need to mention. He doesn't like that we bring this up. Bruce owned for a long time a very famous and very successful company, Operon. Dan knows Operon, and other basic scientists, molecular biologists knows Operon. And then he just sold it for a lot of money. He didn't use this money to spend time on the beach. He brought it back for basic science and contributed to the success. And he established the Center of Nutrition, actually, with this money. Again, this is Bruce Ames. He will tell us today how inadequacy of vitamin and mineral intake accelerates aging-associated diseases, which in other words, he referred to the triage theory. Bruce.
Thank you, honey. Once after a particularly flowery introduction in Texas, Lyndon Johnson said, that was such a wonderful introduction. My father would have really liked it, and my mother would have believed it. Anyway. So my passion is preventing disease. I did a lot of work over the years on DNA damage, which led to cancer. How do you prevent it? What are the significant causes, and how do you prevent it? Okay? And now I've been interested in aging for the last decade or so, and I'm convinced the low-hanging fruit in aging is in nutrition. That's where we can help ourselves and where the gold is, or to mix some metaphors. But anyway, and I'd like to tell you, nutrition as a science is a bit of a mess. It's just so complicated to do epidemiology. It shows an association, doesn't really show causality, so half the time they get the wrong answer. So there's all this knowledge that isn't knowledge out there muddying the field. But I think it's getting better, and they're good people, but mostly the epidemiologist joke is Miami's a weird place. Everybody's born Hispanic and dies Jewish. So that's called confounding, and so you have to take all this information you read in the newspaper with a big grain of salt. And did they really? Is it really plausible? Does it make sense? And all of that. Anyway, so wrong. How do I get rid of this?
You just
What?
click on the screen.
Okay. That's it, you know. So this is I'm a metabolic guy. We're interested in metabolism. And all our metabolism is fouled up. It isn't humming along like it should. And so what do we need to run our metabolism? Each of all these cycles and reactions are one of our proteins that are made by a gene, converting substance A to substance B, and you generate energy out of all of this. So what do you need to run your energy? Well, you need fuel, fat and carbohydrate, and you burn it in the mitochondria, as we heard from honey, and burning it means pulling electrons from the fuel and adding them to oxygen. So all the oxygen we breathe in goes to the mitochondria. You add 4 electrons to an oxygen molecule, you're home safe to water. But there's always some side product. And nature's a much better engineer than people are. So maybe it's 98%, but you're generating a huge amount of electron transfer. So you occasionally make a superoxide molecule or a hydrogen peroxide molecule or a hydroxyl radical. These are all side products of this process. And we have defenses against those. Nature is really pretty good. But with age, it gets worse, and everything sort of goes downhill. Anyway, we're making kilos of ATP every day in our body in the mitochondria, and that's the high energy molecule. It's sort of the energy molecule to power your uphill metabolism, to power your muscles, your brain, and everything else. And then besides that, you need about 40 substances called micronutrients. There are about 15 minerals and 15 vitamins that you need in your diet, and then some essential amino acids and essential fatty acids. But you need those in your diet because they're cofactors for various proteins. Otherwise, you're disabling some of this metabolism. You don't get any one, you die. And so I'd like to tell you a principle that I think we've learned about vitamins and minerals, and what's the principle of eating a good diet. Okay. Okay. So these are roughly 15 minerals and 15 vitamins, and then the essential omega-3s, which you've heard about, and omega-6s. You get omega-3s from deep sea fish. And then the essential amino acids. So I won't argue about the exact number, but, and I'm mainly going to talk about for 30 or so vitamins and minerals. You've heard of most of these things: calcium, chloride, chromium, cobalt, copper, iodide, iron. You need all these to run your metabolism, and then all the vitamins. Okay. And what I'm going to tell you is when you're just a little bit short of any vitamin and mineral, you pay a price for it. And the price is long-term health. So that basically it ages you faster in some way. And I'll go through that. So I think we're telling people, you need so much vitamin or mineral, but it's all based on short-term health. And what we really should care about is long-term health. And I'll go into that. Okay. So are we getting enough? And the answer is a great big no. Americans are eating an abysmal diet. I mean, some of us eat good diets, but overall we're eating a horrible diet. So the committees set up two numbers, the EAR and the RDA. The RDA is what's on a potato chip package, how much the population needs. Okay. The EAR is some distribution in the population, and the committee says, well, if you're below the EAR, you're not getting enough. And then they set the RDA, the recommended dietary allowance, at 2 standard deviations above the EAR. So if you're below the RDA, that's one thing, but if you're below the EAR, the red light has gone on, that you're not getting enough. And look at the American population. Iron, menstruating women lose all that iron, but 16% of them are below the EAR. And magnesium is a complete disaster. 56% of the US population is below the EAR for magnesium. Now, I think the EAR are going to all be changed because I think we're thinking about it in the wrong way. But this is what the best knowledge right now of what we need, and it's clearly we're not doing well. Now, where do you get your magnesium? Magnesium's in the center of the chlorophyll molecule. Chlorophyll is that green stuff in plants. It traps light for photosynthesis. And it's a heme cage with a magnesium in it. Honey talked about heme, which is carrying the oxygen in the blood. It's a porphyrin cage with an iron in it, that's red, and the porphyrin cage with the magnesium in it is green. So any you eat that's green has magnesium in it. Big plate of spinach with a little olive oil and garlic, that's wonderful. I have an Italian wife, so I'm a little prejudiced. So I get all these wonderful green vegetables. But then you're getting a nice dose of magnesium. But Americans aren't eating greens. They're drinking sugar, soda pop and refined food and too much carbohydrate. So zinc is a very critical enzyme because it's in 2,000 different proteins. There are any proteins that look at DNA sequence and turn on lots of genes have zinc fingers. So there are 2,000 proteins that need a zinc in it. And again, 12% of the population is, according to the committees, is too low in zinc. And then B6, elderly women, that makes all your neurotransmitters, and it's involved as a coenzyme for all sorts of important reactions, making serotonin, making dopamine. Half of elderly women are too low in B6. Folate, 16% of adult women. Vitamin E, practically everybody. Vitamin C, a third of people. And then they hadn't set EARs, but we're very low intake of vitamin K, which I'll talk about, vitamin D, which I'll talk about, calcium, potassium, omega-3. The American diet is a wasteland. We're starving. And what we're starving for are vitamins and minerals, because we're eating too much refined food. And the worst are the obese. And in fact, I'll talk just a little bit about obesity. They're eating the worst diet in the country, and every possible disease is linked to obesity. So what changed my life was when a guy named Jim McGregor, a scientist, came to my lab on sabbatical. And he had just done what I thought was a wonderful experiment. And I said, hey, that changes the world, and I'm going off in a different direction. This is red blood cells, as you know. And red blood cells are the one cell in the body that doesn't have any DNA, because you extrude the nucleus to make a red blood cell. Red blood cells are really the FedEx trucks of the body. They're delivering not only oxygen to the tissue, but they're just filled with all sorts of vitamins and minerals that they deliver to the tissue. And then when you dump the oxygen, you're dumping all these other things. People don't look at it that way, but I think that's what it's going to be, turn out to be. Well, somebody had found that if you put red blood cells from a mouse onto a microscope slide and stain it for DNA, 1 in 2,000 cells lights up. Now, that was kind of a stupid experiment because there isn't any DNA in red blood cells, but somehow someone did it. They saw that there's an occasional cell with a piece of a chromosome in it, and they tracked down why. So when you extrude the nucleus from the precursor cell to make the red blood cell, if there's a chromosome break, then that little piece of chromosome gets left behind, and you can measure it by just staining with a fluorescent molecule for DNA and counting the cells that have a little bit of DNA in it. And 1 in 2,000 lights up. You irradiate the mice, you get more of them. And chromosome breaks are the most dangerous aspect of radiation. So that leads to cancer. So that was a neat thing, and McGregor was doing this. He's a cytogeneticist, and he was irradiating mice and looking at the effect of caffeine on inhibiting some repair systems and other things like that. And one day, all his control mice were full of chromosome breaks. So he chewed out his technician, did you irradiate the control mice by mistake? And she said no. And McGregor's a very good scientist, so he tried to track down everything in the mouse's diet, what was different that day. Called up the company that made the vitamin mix for the mice, and they said, oh, Dr. McGregor, we made a mistake. We left out one of the vitamins from the vitamin mix. And he said, what was it? They said folic acid. He said, oh, okay. So, and he then did a dose response on folic acid, and when you make them a little folic acid deficient, you break chromosomes just like radiation. And he thought that was pretty interesting, and he wanted to go right to people, but this doesn't work in people. And the reason it doesn't work is humans have a spleen. And when we've done all these inbred mice, we've eliminated splenic function. So what's the function of the spleen? Well, all your blood goes through the spleen, and any red blood cell that's a little stiff gets taken out by the spleen. The body doesn't want a stiff cell clogging up some capillary somewhere and giving you a thrombosis. So even if you've radiated the people, you don't see any of these micronuclei. But McGregor, then being a very good scientist, he went to our local health maintenance organization, Kaiser, who has 6 million people in their database in the Bay Area, and said, do you have any people without spleens? And they said, oh, we have hundreds of them. You can lose a spleen in an accident, you live perfectly well. So he said, can I contact some of them to see if they're willing to let me take a little blood? And they said, sure. So he went to Kaiser, got 20 people, and they gave him some blood, and he found micronuclei, these chromosome breaks. So he set up a baseline. And the baseline, so this is, so it was sort of like mice. These were the people, and then you could, but one of the people was way up here. Something was funny in this guy. And so he said, that's interesting. We followed him for a whole year. And then when he stumbled on this folic acid business in the mice, he thought, well, gee, maybe this guy is low in folic acid. So what he did, he measured it, and it was somewhat low, but half the poor were at that level, and 10% of the US population were at that level. But he said, what the hell, I'll do an experiment on this guy. And he gave him a form of folic acid for a couple of weeks. And so there are two kinds of red blood cells, the reticulocytes and the normal red blood cells. Reticulocytes are the newly synthesized ones, and you can pull them out with magnetic beads. They're 1% of the total because they have some marker on the surface. And hematologists do this all the time. So the retics, in a few days, were right down to baseline after he gave this guy folic acid. And then the red blood cells take time to turn over, and then they came down to baseline. And then this fellow was eating a diet without much folic acid, so they started going up again. Here are the retics. And then he said, he thought it would be unethical to do any more experiments on this fellow, now that he knew that he was breaking his chromosomes by not eating a bad diet. And he said, why don't you eat a better diet, eat more greens and all those things? And the guy said, give me a pill. And so he gave him a folic acid pill and said, well, take it the rest of your life unless you improve your diet. So he published this in 1988. I thought it should have changed nutrition, and everybody completely ignored it, partly because you had to find somebody without a spleen to do this kind of experiment in a human. But it just changed my thinking, and I started thinking, well, maybe other vitamin and mineral deficiencies are fouling you up. Everybody's thinking of cancer. Oh, there's a part per billion of pesticide, which I never thought was very plausible anyway. That was giving you cancer. And they're not thinking about what you're leaving out of your diet. So some years later, Fenwick in Australia and a Canadian postdoc in my lab, Chantal Courtemanche, compared X-rays, which break chromosomes, with folic acid, and you can see that they're the same thing. And they work, in fact, by the same mechanism, I'll tell you. So the white is X-rays. The more you irradiate the mice, the more chromosome breaks, and the black is folic acid. This is an adequate level. You get a little low, you break chromosomes. You get lower, you break more, and you get lower, you break more still. And so people worry about incredibly tiny levels of radiation. They were even worrying about the radiation coming from Japan, and yet they don't eat their greens. So there's some disconnect there. And so we helped McGregor work out the mechanism. I won't go into this, but it turns out, does anybody know what the word folia means in Latin? Means leaf. Foliage is the same root. My mentor at Caltech first isolated folic acid. I did my Ph.D. at Caltech, and he was on to other things, but earlier in his career, he had isolated folic acid from 4 tons of spinach. So eat your Swiss chard and your collard greens and your spinach and anything deep green, you're getting your folic acid, you're getting your magnesium, and it turns out you're getting your vitamin K too. Now you need other foods for other things, but that's good advice. Anyway, so if you don't have enough of this pool of folic acid, you don't put a methyl group on uracil, which is an RNA, to make thymine, which is in DNA. So you're interfering with DNA synthesis. And you put, then this pool goes up, this pool goes down, you put uracil in DNA. And repair enzymes don't like to see uracil in DNA because it doesn't belong in there, and they're always taking it out and making a nick in the DNA. So we worked out a mechanism on why folate deficiency causes chromosome break. And then the other pool of folate is methyl tetrahydrofolate, and that and vitamin B12 convert homocysteine to methionine. They're cofactors for methionine synthesis. Well, so if you don't have enough folate, you disable this, and if you don't have enough B12, you disable it. Now you're always making more homocysteine. Homocysteine is recognized when it accumulates in your blood. It's recognized as a risk factor for cognition. There's a British group that shows the brain shrinks with age. If you have high folate, it shrinks even, high homocysteine, it shrinks even faster. It's associated with Alzheimer's and all sorts of nasty cognitive dysfunctions. And and breaks your chromosomes as well if you have too high homocysteine, but that's due to other things. Anyway, you're always making more homocysteine. This methionine goes to something called SAM, S-adenosylmethionine, which is the main methylating agent in the cell, and it's moving one carbon units around.
Connie, the one at the end of the table amplifies.
Sorry. I'll try and remember to stay here. Okay. Anyway, I won't go into any more of the biochemistry, otherwise you'll all doze off. But does anybody know what a polymorphism is? A polymorphism is an alternate form of a gene. Now there's a company in California, 23andMe, you can spit in a tube and send it to them, and our whole family just did this. And you measure 600,000 polymorphisms in humans for a couple of $100, and then they notify you you're at more risk of deep vein thrombosis, which is my grandson, or you're less risk at this or that, and that gives you your ethnic background, and it gives you, there's a possible second cousin floating around out there who is in our database because of your DNA. Anyway, this isn't an ad for 23andMe, but you can do all this, and skin color is polymorphisms, eye color is polymorphisms, and each of us has, that's what makes each of us us. All these differences with the next guy. The genes are there, but there's some change in that particular gene, single nucleotide polymorphism, that makes me different than you. And anyway, so why this is selected for in Northern Europe. 40% of Northern Europeans have a polymorphism, and the rest of 60% of the world have the normal one. So why was this selected for? Well, this gives you cancer, and this gives you heart disease and cognition, but those come pretty late in life. And we had a paper, the sperm, that nature really cares about sperm, and that sperm are damaged. This particular polymorphism increases this pool at the expense of this pool, so it means your sperm are less damaged, but at the price of giving you heart disease and early cognition. But that's early cognitive dysfunction. Anyway, the radiation biologists have worked out how radiation works. Radiation gives a cluster of electrons, which is oxidizing DNA bases. And if you get two nearby lesions, of course, the two strands are wound around each other, then when repair enzymes come along taking out these oxidative lesions, the other strand holds it in. But if you get both of these out, you get a double strand break, and dangerous one. And getting low folate does the same thing, more or less. You're putting uracil in DNA, repair enzymes are taking it out, and you get the same kind of thing. So the mechanism basically is very similar. So the next micronutrient I looked at was iron, and so it turns out if you have too little iron, and that's up is bad. And so too little iron is 2 billion women and children in the world, and too much iron is over here, and that's a lot of men eating too much red meat. So too much red meat is, too much iron is bad for you, too little iron is bad for you, and you should be in here somewhere. And what excess iron does, or too little iron, is it fouls up mitochondria. And we were measuring extra oxidants pour out of mitochondria, which they do with age anyway, and DNA damage in the mitochondria and mitochondrial efficiency. So your mitochondria, like someone said, it's like an old car engine. An engine in an old car, it's putting out more black smoke and less efficiency. And that's what happens to your mitochondria with age. And you can accelerate it by eating a bad diet. And then we looked at zinc. I won't go through all these. And we looked at human cells in culture, and you could show DNA damage and oxidants being produced. And honey here did an experiment with biotin. This is a fluorescent reagent called fluorescein, which is wildly fluorescent. And someone reduced that, so it's a reduced form rather than an oxidized form. And it's not fluorescent. It gets into cells, and the cells have a lot of oxidants. They oxidize it, and it becomes fluorescent again, and you can see it. So biotin deficiency does that. And so I won't go into the mechanism. Hani had some ideas about this. And another student in the lab, David Killalay, showed that magnesium deficiency, which is an interesting one because there's so much of it, gives you cross-links mitochondrial DNA to protein. So you get radicals in your cross-link thing. So we're mechanism people, so we're always trying to figure out the mechanism, and that makes everything plausible. Then I kept on worrying, why is nature doing this? Why does nature want to give us cancer when we don't have enough of vitamin and mineral? And so I said, has anybody else found this kind of thing? And I put the 30 vitamins and minerals into Google. Google's so wonderful. And then I put next to it mutation, DNA damage, chromosome breaks, cancer, and all this stuff came out of the literature. Now, you can't believe it all because a lot of it's epidemiological, but it's an association and it makes you take it more seriously. But there's a lot of stuff out there that you don't get enough of some vitamin or mineral or another. You get more cancer, you more DNA damage. And so I just kept on thinking about this for a long time. Why is nature doing it? And one day I had an epiphany. That's what nature wants. Nature wants to give you cancer when you're short of something. And the reason is, it's the trade-off between short-term and long-term. So what I postulated, and now I think we've come close to proving, is that whenever you're short of any vitamin or mineral, the proteins that need it for survival and reproduction hang on to it, and the proteins that need it to give you a long lifespan lose it. So it's a trade-off between short-term survival and long-term health. And evolutionary biologists have talked about that trade-off in a lot of other contexts, and it's a very plausible thing, and I think it's going to be true of our biochemistry. So it means you're paying a price when you don't eat a good diet. So I call this triage. It's on the battlefield. The surgeons had to make decisions. That's a French word, but I won't go into that. Anyway, and we published this back in 2006. Most of the world's population has an inadequate intake of one or more micronutrients. And we postulated that throughout all of evolution, animals were running out of vitamins and minerals. The minerals aren't spread evenly through the world. There are red soils with a lot of iron and soils with very little iron. Selenium, Britain and Europe, there's some areas where you get poisoned because there's too much selenium in the soil, and there's some areas where you're starving because there's not enough selenium in the soil. So that's how it is. And animals were always moving from one area to another. So we built into our metabolism this switch of prioritizing. And we've analyzed now 2 vitamins and minerals in great detail, and I'll show you that it's really built in. So there's damage, but it's insidious damage. Like DNA damage goes up. Unless you measure it, you don't know it, but eventually that leads to cancer. People know. So I have a wonderful woman in my lab, Joyce McCann, who used to be a postdoc with me maybe 35 years ago. She came back to the Bay Area looking for a job, and she's just brilliant. So I said, Joyce, I'll hire her. I don't care what you work on. She's just so smart. And she doesn't like messing around in the lab. She does theoretical things or writes reviews. And so she came into my office one day and said, I'm a little skeptical of your triage theory. I think there's a better way to tackle it. I said, okay, Joyce, do what you want. And so what she wanted to do was find those vitamins and minerals that have been very well studied, and practically all of them have. There's a huge literature on everyone, but are not too complicated. Now, vitamin D you'd never want to touch, because vitamin D goes to a hormone that's turning on 900 genes. So it's way too complicated. You'd spend the rest of your life in the library. And magnesium is in 500 enzymes or so. All the DNA repair enzymes have magnesium. And zinc is very complicated. So she picked some that just involved a dozen enzymes, or maybe 2 dozen, and started to analyze them in detail. And the first one was vitamin K, and it's so beautiful. It has all these medical implications, and the docs don't know anything about it. We didn't do any of the work. There's a wonderful group in Holland that's been doing all this beautiful work on vitamin K, and a group in Boston. But we just are flying over at 20,000 feet trying to see what's coming to all the vitamins. Okay. So what does K stand for? It stands for coagulation in Dutch. A Dutch scientist, Van Dam, figured out that there was a factor necessary in greens that was essential for blood clotting. And you spell coagulation in Dutch or German beginning with a K. So, and now what Joyce McCann did is she went to mice and looked at the mouse knockouts. Capecchi got a Nobel Prize for figuring out how to knock out any gene in the mouse. And it's been enormously useful in a lot of ways. And so now they're on the way to knocking out every gene in the mouse and see what happens. Well, you knock out any of these genes for coagulation proteins, they're all embryonic lethals. They just don't, the pups just don't survive. Okay, that's essential for survival. And that makes sense. You're making 20,000 miles of capillaries in a mouse, or a human, or whatever the number is. It's something like that. And you have a little imperfection, the mouse, you don't have blood clotting, the mouse doesn't survive. And you cut yourself pretty often where you bleed, put a Band-Aid on. If you didn't have blood clotting, you'd just die. You'd bleed to death. So anyway, so we're not interested in these. These are the essential ones. The ones I'm interested in are all these ones that get trashed when you don't have enough vitamin K. The osteocalcin, GAS6, matrix bra, TGF-beta, and one's more interesting than the next. So what vitamin K does, it's a compound called phylloquinone that's in plants, and when you eat it, it's lipophilic. It goes to the lipoproteins and delivered to your liver. And you do all these coagulation proteins in the liver. But these other proteins that are all essential for longevity, those are done not in the liver, but in other tissues. And the liver gets first crack at it. And the way nature does this is the K gets converted to something called MK, a menaquinone, and that goes to all the tissues equally. And you need more of it. Now you can get MK from other sources. I'll tell you about that in a minute. Anyway, osteocalcin's in the bone. It moves, and what the cofactor does is a glutamic acid in protein, which has an acid group up at the top, carboxyl group. The vitamin K in a protein can add another carboxyl group to glutamic to make something with 2 carboxyl groups sticking out, so it can bind calcium. So all these 16 proteins are calcium binding proteins. And that's the necessary. Well, osteocalcin moves calcium around in the bone. You knock out the mouse gene, and the pups are born. They look perfectly happy, but you stress them a bit, the bones break. And vitamin K deficiency is associated with bone fractures. And there are 30 million prescriptions for warfarin, it's also called Coumadin, every year in the US to prevent blood clotting. And those people have a much higher rate of bone fractures because you're trashing those proteins when you don't have enough vitamin K or interfere with K. And GAS6 protein is a tyrosine kinase inhibitor. I won't go into that, but it's associated with acute coronary syndrome, and it's associated with an aspect of diabetes. And then matrix GLA is really interesting. This is, did I? Okay. So here we've looked at the protein, the function, the mouse knockout, the human mutants, anticoagulant therapy, which is the warfarin and vitamin K. So matrix GLA, you knock out that gene in mice, and the mice look perfectly healthy, they live perfectly well, and then they all drop dead. And what do they drop dead of? Calcification of the arteries. So it turns out that calcium phosphate crystals, it's also called hydroxyapatite, will crystallize out if you look at it. And it's the beginning of an atherosclerotic plaque. So this protein's function is to wander all around your soft tissues, and whenever it sees a hydroxyapatite crystal, it grabs it and takes it out of there. So it prevents calcification of the artery. You knock it out, the animals die of calcification of the artery. So then Joyce McCann looked in the human gene, and there's a rare genetic disease where people die of calcification of the arteries in an early age, and because it disables the human gene. So right away, everything kind of fits. And then one of the symptoms of not having enough vitamin K is calcification of the arteries. And one of the people who get anticoagulant therapy are dying at 9 times the rate of calcification of the arteries. So it all makes sense. And so if you're going to give warfarin to people, what the docs really should do is give this MK, an MK derivative which gets to all the tissues equally, yet doesn't interfere with your blood clotting. I mean, the Dutch guys have figured this out. And this is natto. Has anybody ever eaten natto? We have a victim over there. Natto is a Japanese health food. You get it for breakfast. And it's a Bacillus subtilis. It's a bacterial fermentation of soybeans. You put your spoon in it at breakfast, and you lift it up, and you get all these white, yucky strings. And then you smell it, it smells yucky. You taste it, it tastes yucky. So Westerners just don't want to eat it again. But it's like learning to eat Limburger cheese. You can learn to like it, but the first time you don't like it. Anyway, the people who eat natto is filled with MK7. So bacterial fermentations often can give you this menaquinone form of vitamin K, and this MK7 goes to all the tissues equally, and the people in Japan who eat a lot of this compared to the people who eat regular salt don't eat it. They have much less heart disease, they have much less bone fractures, everything that fits in with what we understand from the mechanism. So, anyway, so you can try and learn to like natto, but you can also buy MK7 in the health food stores. But medicine doesn't know any of this. Docs have abdicated as far as nutrition goes. It's sad, but they don't treat nutrition in medical schools. Maybe you guys will, but docs and nutrition is changing, and it's very muddy, so docs just figure it's a muddy science, but people are vitally interested in nutrition, and I think we have to go, anyway, that I'll be case. Joyce also did selenium, and the same thing, it turns out to be true, that all these long-term, this cancer and DNA damage and heart disease and immune dysfunction, muscle weaknesses, and that happen with some of these when some of these proteins are disabled. And So I think what we've convinced ourselves is it's built into metabolism. Now, the selenium is done in a completely different way. It's done by a modified base and transfer. I won't go into the details, but it's built into your metabolism that when there's a little bit of a shortage, the ones essential for survival keep it, and the other ones get trashed. And about half the proteins in these two analyses, Joyce has a third analysis she's about to send off, about half the proteins are what I call longevity proteins. They are involved with long-term health. And we should be thinking about nutrition in terms of longevity, not just short-term things. All the vitamins and minerals have been discovered because of short-term effects, scurvy or all sorts of other beriberi. And what we should be thinking about is long-term effects. So I think there's going to be a whole new class of vitamins and minerals, and we think we've discovered one of them, and we're about to publish it. And I have a lot of ideas for other ones. So it opens up a whole new area. But all the numbers, the EAR and RDA, should be based on long-term stuff. Anyway, I haven't convinced the nutrition community. I'll have to work a long time because people are very conservative, and blasting an old idea out of a scientist's head is very hard unless you have really good evidence, and we've been amassing that, but we'll get there. When everybody says it was obvious, then I know I've succeeded. So the immune system. Your immune system's really important, but it goes out with age. And if you put in Google what in adaptive immunity goes out with age, these 6 things pop up. And then you put in the 30 vitamins and minerals in Google versus these and ask what comes up. And my postdoc, Swapna Shenvi, and I did this, and lo and behold, there's some work out there. So occasionally people have looked at one of these things, but nobody put it all together. So I think you're trashing your immune system, a good part of your immune system, when you're short of vitamins and minerals, because if you don't remember that virus that hit you 4 years ago, well, you pay a price for it. But if it's a matter of survival, then that's your trade-off. And so somebody did vitamin A. This is CD4 and CD8, the T lymphocytes, which are part of your defense systems. And the ratio changes with age, and it changes when you're short of vitamin A or zinc. And then the folate was one of my own papers that I'd completely forgotten about. I had a Chantal Cordemanche, this French-Canadian gal, who was very good, and she had shown that the CD4-CD8 ratio changes when the mice were short of folate. I didn't understand it. She didn't understand it. We published it in the Journal of Immunology, and I promptly forgot about it completely until it popped up in this Google search. So anyway, this doesn't prove any of this, but I think it does keep on indicating it's long-term stuff that suffers when you don't have a good diet. Now, Joyce also did 4 reviews on the developing brain. When you're a fetus in the first 2 years of your life, you're making 1 trillion neurons, roughly, and each neuron has 100 to 1,000 connections. So it's one of the most complicated things in the universe. And nutrition matters. There's a whole very definitive literature on iron. You don't get enough iron, and that's 2 billion women and children in the world. Your brain doesn't work well. The kids don't do well in school, and they've shown it in mice, and they've shown it in rats. And so Joyce did 4 big reviews on this, and one of them on vitamin D is really interesting. Because vitamin D, you need 20 minutes of sunshine a day, and in the winter in Scranton, you probably don't get that much sunshine. And you certainly don't get it in Sweden or whatever. So we have a problem. And so skin color is all about ultraviolet light. In the tropics, in Africa, southern India, New Guinea, racially completely different people, a dark skin helps you because it keeps you from getting burnt by ultraviolet light and eaten by a lion or whatever it is. So there was a strong evolutionary selection. But you put an Irishman, and when the people moved up north, they were eating a lot of seafood. They were going along the coast, and you can get some vitamin D from seafood, but there was a strong selection for a wide as skin as possible to capture every little bit of that ultraviolet light to convert 7-dehydrocholesterol to vitamin D. And as I say, it goes to a hormone that's turning on 900 genes. You can see the vitamin D receptor in front of 900 different genes in the human genome, lots in the brain. And if you have a dark skin in the United States, so an Irishman in Australia is in deep trouble, and the solution is a hat and sunscreen. An African American in Chicago is in deep trouble, and the fact that it's genetic doesn't mean you can't do anything about it. You can buy a vitamin D pill for a penny or two and take a vitamin D pill. So, but newspapers didn't want to touch our paper because I sent out lots of press releases, minimal, because people are convinced if it's genetic, people have to be the same, and if it's genetic, we don't want to deal with genetics and intelligence. But anyway, whatever it is, 95% of African Americans are really low in vitamin D. And so I think we need a crash campaign to get vitamin D into dark-skinned people. But anyway, that's another matter. This is the brain. It's full of vitamin D receptors. This is all the proteins in the brain that require vitamin D to turn on. It's complicated. There could be differences. African Americans have strong bones, even though they don't have much vitamin D. So it's, but we had 80 cases of rickets in the last couple of years at Children's Hospital in Oakland. Rickets. We've eliminated rickets. And they're all black mothers nursing their babies. They don't have any vitamin D. If you give them formula, it had vitamin D. So it is a problem to be addressed. Okay. Fennick did a study looking at chromosome breaks in people. These are healthy, non-smoking males and females. Look at that variability. But it goes up with age, and women have less damage than men. And women live longer than men. So women are getting less DNA damage. So I think a lot of this is nutrition. We'd like to prove it, but right now we don't know what's causing all that variability. So I'll just finish off with a few things. So what's the benefit of a triage? So one, you can get to mechanism. And if you know mechanism, then epidemiology becomes enormously easier. So we need to identify the, I have a friend who has a company who can measure 1,000 human proteins in a finger prick of human blood. And he's going to soon have every protein in 20,000 or so protein in a finger prick of human blood. I have another friend who's putting a kiosk in every pharmacy in China where you put your finger in, get a finger prick of blood, and it analyzes proteins and tells you, sends the message to your iPhone on what you should be doing. So hopefully we'll get to the point where medicine becomes preventive medicine, and we're each measuring our numbers on a finger prick of blood, which is easy to get, and it'll tell you how to tune up your metabolism. That's what we want to do. And then I think we'll all live a little longer and have less of all these degenerative disease. The body still goes downhill, but it's going to push it back. That's at least my vision. I'm 83, so how far we can get, I don't know. I'm finding my mitochondria decaying ever more rapidly. But we figured out what they're decaying into. My mitochondria are decaying into hypochondria. Anyway, obesity. The conventional wisdom on obesity is it's just calories in and exercise out. So, but I think it's more than that. Obese people are starving. The paper after paper says obese people are starving for vitamins and minerals. And that's a disaster because you're destroying your brain, you're destroying every part of your metabolism. So how do you get people to cut out sugary soft drinks and all these things? And I think when you're starving for calcium, there's a little evidence in the literature, nature makes you hungry. You counteract satiety signals for getting all that sugar. So that isn't proven, but I suspect it's going to turn out to be true. So then we have people who are who are hungry, but they're hungry for magnesium, and there's no magnesium in the diet because they're not eating greens. This is the American diet, rest in peace. Sugary soft drinks, 9% of calories, pizza, beer, hamburgers, meatloaf, white bread, cake, donuts, pastries, french fries, fried potatoes, extortion, popcorn, rice, cheese. Nothing green in there. And when you fill up with all this refined food, then you're starving for vitamins and minerals. So as your mom told you, I think the moms that didn't tell their kids to eat the veggies got selected out by evolution. So what you want to do is eat more fruits and vegetables, more nuts and berries, those are good things, and less carbohydrate, less white stuff. Give up the white stuff and give up too many carbs and cut out sugary soft drinks, and you'll be fine. But anyway, in next decade or two, are going to come all these wonderful things where we're going to be analyzing people and individually, which we'll have to do because of all our polymorphisms, and tune everybody's metabolism up. And let's see. So obesity is a complete disaster. It's every possible disease that's been measured is linked to obesity. More cancer, more cognitive dysfunction, more Alzheimer's. There's just a paper about autism. You name it, and if people have looked at it, obesity is a risk factor. And I think partly because they're eating such a horrible diet. They're not getting the vitamins and minerals. Anyway. And so what to do about it? My colleague, Mark Shiganaga, is an expert on obesity, and he figured it out 5 years ago or so what the cause is. He thinks it's bacteria getting through your gut into your body, causing inflammation, which is driving a lot of it. And what causes a leaky gut? Well, you don't have fiber, that's really bad. You don't have vitamins and minerals, then your mitochondria can't keep the barrier function up. And I'm interested in getting the vitamins and minerals to cut out hunger, because if nature's making you hungry. So we decided you couldn't do all this in pills, and getting pills into the poor is going to be a disaster anyway. The government agencies, NCI and other agencies, have been telling the poor, oh, eat more fruits and vegetables, with zero success for 30 years. So, and pills you could do, but it's hard. People don't remember to take pills, particularly if you have to take a whole mess of them. And fiber, you can't get into pills. So we developed a little bar. There are 400 bars in the supermarket, but ours is a low-calorie, high-nutrient, high polyphenols and high fiber bar. And it does wonderful things to people. So this is one experiment we've done 8 clinical trials and measured all sorts of things. But the bottom of the arrow is the level, this was HDL. And more HDL is good for you. So the bottom of the arrow is when we started the 2-week experiment. And then they ate the bar for 2 weeks, and the top of the arrow is where it lost. And you don't need a statistical analysis to see that these bars are going up. And anyway, we've done lots of studies like this, and but whether we can get the bar through FDA, if you can make any health claim, FDA calls it a drug, and you have to do billion-dollar clinical trials and all those things. So you want to stay as far away from FDA as possible, but you're not allowed to make any health claim at all. So Safeway wanted to adopt this and sell it, but the marketing people killed it because they said, you can't say anything about health on the bar. Otherwise, FDA would kill us. So anyway, it's... So this is Mark Twain, and this is, as we heard, life expectancy gets longer every year. Now, the pink dots are women. Women live longer than men. The other are men. And now we're up to 80. Every year it gets longer. But the obesity epidemic, a third of the kids at Children's Hospital are obese. And asthma, all these nasty, expensive diseases. So I think obesity is going to be worse than smoking by a fair amount and much more costly. So do we want the thin people to pay for the fat people, or do we want to figure out how to get them not to become obese? And that's the big question. And anyway, we hope our bar will help, but we'll have to see. You can't get any of this funded because it's not the kind of thing science funds. But anyway, I'm doing it out of my own pocket, but it will get. So in 30s, they set up Social Security, and life expectancy is just below 60. They thought everybody'd be dead by 65. And every projection has been wrong. It really, you're putting all the burden on the next generation to pay for these older people, but you're going to have fewer and fewer, more and more old people and fewer young people. Anyway, this says you're 57 years old. I'd like to get that down a bit. And then the last slide is this is the group. Jung Soo is working on this new vitamin and lots of other great things. Joyce McCann wrote all these wonderful reviews. Swapna's an Indian postdoc who's been working on immunology. David can measure all the minerals at once in a neat machine called an ICP. Hal is a physician who keeps premature babies alive most of the time, but he spends some time in my lab helping David. Sandy works on mitochondrial DNA mutation, and we think that might be a warning system for mutation in the cell. Mark is my guru. He looks like Buddha. He's a Japanese American with a big round face and a big round belly and horrible HDL and LDL and all these things. He's always at the left end of all our studies. But he's a wise man. And so anyway, he's our obesity expert. Michelle's a physician, a pediatric cardiologist who's been doing a lot of our clinical trials. And she's an athlete, and her HDL's up through the roof, and it goes still higher when she eats the. So they bracket all our studies that we do. And Ash Lau's an Indian hematologist who's been working in the lab part-time too. So anyway, eat a better diet and you'll live long. Answer any questions?
Well, the tradition keynote speaker doesn't receive a question, you talk to him afterwards, but if there's questions, we'll
Yeah.
go ahead.
Have you done any research on heavy metals when people are eating and the toxins involved in their body?
Okay. So heavy metals. Now there are lots of little bits of toxins out there, pesticides and bits of synthetic chemicals, but I've yet to be convinced that any of them are of much significance. There are parts per billion, and a part per billion is one person in all of China. So unless it's Mao, you just don't want to worry about it. And I don't. So I think the big thing is going to be diet. That's where and obesity is a disaster. So that's where we should be putting our money. So heavy metals. You don't want to be eating Mexican pottery that's full of lead, or which it is because they use low fire kill, and you don't want to be getting mercury out of your fillings, though some of that's now they're switched over to ceramic fillings. And you don't want to eat swordfish every day because you get more mercury. But fish is good. You're getting your omega-3s, so you don't want to go overboard. And
once upon a time, I was on the American Heart Research Committee, the approval committee for grants for the state. And the American Heart at that time had a posture of not funding anything clinical. Everything was basic science. And I'm kind of astounded that you can't get funding sources for this sort of absolutely amazing research.
Well, but when you open the funding 10%, it's the worst funding I've ever seen in my 60 years in science. I'm 83, and I told a colleague I'm doing the best work of my career, and he looked at me and said, "Bruce, you've been telling me that for 30 years, so maybe it's just my enthusiasm genes are okay, but my neurons are going up." But whatever it is, they fund 10% of the grants, and if you're thinking differently than everybody else, it's really hard to get funding. Honey is doing the best work in the world, I think, on Alzheimer's, but he thinks differently than everybody else, and I think he's going to be right. but he's had a terrible time getting funded. He finally got funded, but you have to keep on churning out. I was trying to convince people 30 years ago that DNA damage had something to do with cancer. And I could make practically no headway, but we kept on churning out the papers, and finally everybody said, well, it's obvious. And so that's how life is. When you want to think differently than everybody else, you have to pay a price for it. But if you're energetic and can persist, you'll get there. Yeah.
Terrific.
Thank you. Anyway, nutrition's the stepchild, and
Is there any genetic evidence suggesting that as a person gets older, they lose the ability to take up?
I'm sorry, my hearing's going slowly as I get older. Would you talk a little louder?
Sure. Is there any genetic evidence suggesting that as a person gets older, that they begin to lose the ability to take up various minerals and vitamin cofactors?
Yeah, everything gets worse with age. Your mitochondria decay, hopefully not to hypochondria, and your transport systems suffer. So old people don't take up vitamin B12 so well. And you don't get your B12, you break your chromosomes. So it's all, and your brain goes out. So it's, there are ways of getting around this. There's a B12 pill you can suck, and it absorbs through your mouth, and then you swallow it, and some gets absorbed through the gut. But people, when they realize this, they develop ways to do it. But most people aren't concerned about the kind of food they're eating. You need to eat a very varied diet, and the general principles are fine. Just try and, we don't understand everything, but eat a big varied diet and cut out all the dense calories. The Paleolithic diet was a grasshopper here and a weed there. You ate what you could get, and agriculture in a way did us in because you got lots of rice or one thing. But the Japanese the ancient Asians used to eat rice, complete rice, but brown rice goes rancid in a week. So it was a big technical advance to make white rice so you could store it, but they used to eat all the parts of the rice. Now you eat the white rice and you don't eat all the rest. So, anyway.
Thank you, Dr. So we're running a little bit behind schedule, but that's all right because there's some leadway. We're going to try to end pretty much on time or even a little bit earlier than the schedule states. And what I'd like to do now is I'd like to move right into the education panel, and I'd like to introduce the panel head. Dr. Ray Smigo is an Associate Dean for Educational Development